I'll try to tell you a little bit what we're trying to do in this paper. I'm not sure that we perfectly managed to answer all the questions that we want to look at. The question is basically, how can you target agents if you don't have information about them? In particular, the type of idea that we have is we think about a firm, which is a monopolistic firm, who would like actually to identify agents. And in particular, we have in mind that there are consumption externalities, and that what you need to know is where agents are located in a social network. If you knew that, you would know, for example, where you should give the product, to which agents you should give the product for free. But suppose that you don't have that information about the social network. So there's been quite a lot of work in computer science looking at how can you seed the network or identify targets in a network if you don't have any information whatsoever about the network. I mean, how can you query and so on? And what we're looking at in this paper is how can you do it when the information that you have about the network is the architecture of the network, but you don't know where the agents are. So the idea, so I'm not sure that we have a lot of good examples, but one example that you can think of is that the information that you have is a map. So you know, you have satellite data and you know a map, but you don't know who lives where. Another example that you can think of is that the only access that you have is aliases. So basically people playing video games just play with names. Or you're talking about criminal networks where you know the aliases of people, like in the French Resistance, but you don't know exactly the identity of the people. Okay, so the question that we're asking is that one. So I'm going super fast because I'm, it's okay. So the question is this. It's basically the social planner would like to target agents in the network, but the only information that he has is information about the architecture of the network, but he does not know what is the identity of the agents that he sees on the network. And the main question, and the surprising result that we have in the end, is that not knowing the identity of agents actually does not matter that much. In other words, that the planner will be able actually to implement the first best by making agents actually reveal their identity with very little, I mean, it's going to be, I mean, I'm going to tell you exactly when it is going to be the case that actually he can do it, but there are many, many instances in which he will be able to do that. So knowing or not knowing the identity of the agents, as long as you know the architecture of the network, is not going to matter that much. Okay, so that's one of the messages that we have, which we find a little bit surprising. Of course, it depends on the model, so the model is going to come next. And if you think about it in a minute, what is going on is that not knowing the architecture of the social network means that there's going to be a lot of correlation in the reports that people are going to give. So the planner is going to be able to use that correlation in order to extract information and implement the first best, a little bit like you would see in the spirit of Kramer-MacLean, where you can use correlation, any type of correlation, and minimal amount of correlation between the types of agents to be able to extract the entire surplus. Okay, so let me give you the setting. So it's a setting which is now becoming a workhorse for people working on social networks. It's the idea that you have externalities you have positive externalities in the actions that agents are taking, and they are reflected in the utility that you see here, where the utility of agent I depends on his own choice xi, but also on the choice of the other agents xj. You can interpret those choices as efforts that people make. You can interpret them as consumption, and then we're talking about consumption externalities. And what's important is that those consumption externalities are localized. So you only care about those agents who are your neighbors, and that's written in the Gij, Xi, Xj. Okay? So this is a very standard model, and in that standard model, there's a misalignment between what the social planner would like you to do and what you do, because you don't want to internalize the positive externality you have on others. So the planner is going to force you to consume more or to exert more effort than what you would like to do. Okay, so that's very standard model. The objective of the planner, maximize the sum of utilities of the agents. So you can interpret it in two ways.
You don't observe AI and BI, right?
Well, they're soon going to be identical for everybody.
So then, if everybody is the same, if everybody is the same, there is no anonymity problem.
Except for the location in the network, the GIJ.
But the GIJ is the map.
So the GIJ is the map. So
I mean, people don't have an identity if they have the same preferences.
So people have an identity, people have a location.
Yeah, but my preferences are the same as everybody else. So if you are at my location, this does not change.
True, but the story is this. The story is that suppose that I offer you a package. I offer you an effort for people who live in that location. It may be that actually two people have an incentive to switch to pretend that they're in each other's location. And the reason for that, okay? So suppose because we're creating and receiving different externalities. So the planner, for example, is going to impose to you a very high level of effort. And the reason why he imposes to you a very high level of effort is that you create a lot of externalities on the others, but you yourself receive very little externalities. And then I'm somebody who creates little externalities on the other, but receives a lot. It may be that actually we want to exchange the packages. You want to pretend to live where I live, and I want to pretend to live where you live. Because I will get the package which is yours, but I will enjoy the externalities which are mine. I agree that it's not totally clear why that should happen. But so if you're in the first best, it's a very well-known expression that people use. So the quantities that actually you are going to impose on the agents, those quantities depend both on the externalities that you receive and the externalities that you produce. And that comes from the fact that you look not only at the adjacency matrix G, but G plus the transpose. So you look both at how much you create and how much you receive. And the problem is that how much you create, you don't care about. So agents do not care about how much they create. So that's the edge between the planners and the individual's decisions. Okay, so it's well known that actually those, so the quantities can also be related to what's called the Katz-Bon acid centrality of an agent in the network. So let me skip this. And the problem that I'm looking at is this one. I observe the architecture of the network, so I know there's somebody in the middle. The agents actually know where they are. So think about agents as being aliases. So I know where what my alias is, or I know where I live in the map. And the question is, will I have an incentive to reveal where I live or what my alias is, or will I have an incentive not to reveal it? Okay, so I'm going to look at a simple mechanism. So what I was trying to say before when I talked about Kremer-MacLean is that if in that setting you were to ask agents to reveal everything they knew, for example, to say, what are your neighbors? Give me the list of your neighbors. Show me where you are in the network. There would be sufficient correlation actually for you to be able to extract all the information there is. So you could actually punish the agents for inconsistent or discrepant reports. So what we're going to look at is something which is simpler and different, which is an idea that you offer to the agents a menu of contracts, and the agents are going to pick one contract in that menu. So the menu of contract, the first best menu of contract, what that is going to be is that you're going to be computing for each and every location what is the optimal value of X, and you're going to offer that to the agents. And the question is, are the agents going to be picking the contract which is their contract or another contract? And going back to Gilles, I will try to make my point to answer Gilles in a minute.
I tax people. I give the contract to people, not to locations.
I identify contracts to locations.
There's the network out there. with spots, and in each spot there is somebody, and then there are people. Right? And when by anonymity, what you are meaning by that is that I can give you a contract, but I don't know where you are in the network. Whereas alternatively, I guess it would be trivial. I could just, tax each location in the network. Like you sit in location X.
Sure.
And then you have this contract, right? You cannot escape it.
If you cannot escape it,
then there is no problem, right? Because preferences are the same. Right?
Yes. But what I'm doing here is basically I'm posting a menu of contracts on the board here, and I don't know, I compute those contracts knowing that people are in those locations, and I wait for people to pick it. And I want to check whether people pick the right one or not the right one. Okay? Now, if I were to look at individual incentive compatibility, it will be solved by Kremer-MacLean. Because people are not, if I look at two people who go and pick the same contract, I can identify them and kill them or do whatever I want with them, or give them 0 if you don't want to kill them, and that's going to give them enough incentives to make sure that the contract is incentive compatible. So what we have to look at are group exchanges. What happens if groups of agents decide together to lie, to jointly lie, and pretend to be in locations when they are not. And in the paper we look at groups which are large groups of people, but most can be explained actually if you just look at pairs of agents choosing to lie about each other, choosing to exchange the locations. And let me repeat what I was trying to explain, which is the reason why we may want to exchange our locations is that if I'm somebody who has a low effort level and I'm facing somebody who is asked to produce a high effort level but receives very little externalities, he's going to be willing to get my contract, and I'm going to be willing to buy his contract for a price. So another problem here is that actually if we have two agents, we can never make both of them strictly better off, so we have to allow for side payments between the two agents. So I said I'm rushing, so I'm rushing. So in the end, what I want to talk about are contracts which will have the property that I cannot find groups of agents who could, by jointly lying and then organizing side payments among themselves, be better off. In other words, I cannot identify a group of agents such that the sum of the utilities that they would get through a joint lie would be better than the sum of the utilities that they get in the contract which is offered. So if you think about incentive compatibility, I'm allowing groups to do a lot of things, actually. So it's, in some sense, if I manage to show that the optimal contract satisfies this relatively strong property, I'm going to be happy. I'm hiding some things under the rug. For example, I'm hiding under the rug that I'm asking groups who deviate to be adjacent. Namely, I'm not allowing agents who have no connection with one another in the social network to form a joint deviation. So the point now, there are two results in the paper. The first result is that if you look at networks which are not directed, so networks which are not directed mean that if I create an externality on somebody else, that person also creates an externality on me. So those will be symmetric types of externalities created. Then the proposition here says that the optimal contract, the first best, is going to be immune to deviations by groups of agents. So it's not a totally obvious result, but it has some intuition, because the intuition behind it is that the only way that you can actually have an incentive to lie about your location and exchange with another agent is if you're in completely dissymmetric situations with respect to the externalities. It's going to be when one of them creates externalities and does not receive them, and the other one receives externalities and does not create them. So here actually, as I said, it's not an obvious result. It's actually a technical result due to the recursive property of the Bonacic centrality measure. But I think it has some meaning. So my take away is that actually if agents create, if we're in a world, if we're talking about externalities which are symmetric, for example, consumption externalities of using the same computers or that type of examples of local network externalities, then there's not going to be any problem. The polar opposite would be situations where we have what we call hierarchical networks. And these are networks in which you have a hierarchy of agents. So think about it as you have a main influencer. Let's take a single agent to be the main influencer. And then other agents that he influences, and then further agents, and so on and so forth. So it's the idea that you have everybody's influenced by Oprah Winfrey, but she's clearly not influenced by me. And I can actually put people in hierarchies, put people in classes, where each people from one class is influenced by people above, and influences people below. Then, actually, that first result shows that actually it's group incentive compatible if you don't allow for transfers. But we have two results showing that if you allow agents to make side payments, then not only will you not be able to implement the first best contract, but you will very fast be led to not doing any discrimination at all and having the same uniform contract offered to all the agents. Okay? So here, for example, if you have one agent at the top and everybody is influenced by one agent at the top, and the hierarchy contains more than 2 tiers, then except for tier 2, all the agents at lower tiers are going to choose exactly the same optimal contract as the agent at the top. And here, actually, the intuition for that is that the agent at the top is going to be asked to produce a lot of effort, but he's obviously not going to be influenced by anybody. So anybody else actually will have an incentive to exchange their contracts with him. And that's the only case, and you will want, that's always going to happen as long as the effort level of the guy at the top is higher than the effort level at people at the bottom. But the planner will not want to switch it, so the best he can do is actually equalize those levels of effort. It also happens when in another structure of very hierarchical networks that you can call nested neighborhoods. So here, the difference with respect to the other case is that you don't have a single agent at the top. You may have multiple agents at the top, multiple agents being influencers of everybody. But whenever agent 4 here is influenced by agents 1 and 2, all the agents who are influenced by 4 are also influenced by the same. So we call that nested neighborhoods. Okay, so it's again a very specific hierarchical structure. And again, we get a result which is a result of total uniformity or total absence of discrimination in that particular case, where all the agents are going to receive the same contract in the optimal contract. You're totally unable to distinguish between them. Okay? So I will stick to my promise of not being too long. So what do we learn here? I think we learn, I don't know what we learned, but the answer to my original question is that there are situations where knowing the exact identity of the agents in a network of aliases is not going to matter, and that's going to be the case clearly when agents can deviate unilaterally, when you cannot make side payments, when you have rich message spaces, and mostly when influence is reciprocal. I didn't talk about regular oriented trees, it's in the paper. And then there are situations where it's going to be difficult, and that may actually lead you to the total absence of discrimination. And that's going to happen when you have hierarchical structures. So we've identified 2 of them, single root and nested neighborhood networks. It will also happen, actually, I should mention, we have examples to show that if you allow for group deviations by agents who are not connected to each other, it's going to be very easy, actually, to have agents choose to exchange their locations.